Now let's talk about horizontal isotopes. A rational function has at most one horizontal isotope, and it all comes down to how the numerator and denominator react to each other. If the degree of the numerator is less than the degree of the denominator, then the x-axis will be your horizontal isotope. So over here on this graph on the screen, I can tell you that on this rational function, the numerator had a smaller exponential value than the denominator because the x-axis happens to be our horizontal isotope. If the degree of the polynomial of the numerator, equals the degree of the denominator, then the horizontal isotope is found by y equals the leading coefficients of the numerator over the leading coefficient of the denominator. And the third thing that could happen is that the degree of the numerator is larger than the degree of the denominator, and we do not have horizontal isotopes when that happens. And we're not going to discuss these cases. So, moving on to some numerical examples. We are given three situations on example 7, and we are to find and draw the horizontal isotopes of the given functions. So starting with part A, we're going to start off by noting that the degree of the numerator is equal to 2. Now I'm talking about this right here. And the degree of the denominator is also equal to 2. So that means that these two are equal. So the horizontal asymptote can be found at the ratio of the leading coefficients. So we're going to take the 3 in front of the x squared in the numerator and the 4 in front of the x squared in the denominator, and we're going to say that the horizontal asymptote happens at 3/4. And we can see this on our calculator. Let's go in here and graph it. I'm going to choose the fraction so everything will look like it does on my page. And notice when I have this in, the denominator is going to cause some vertical asymptotes. So we're just going to look at the very ends of our graph. So let me hit graph. And you saw how it graphed. On this end, it's above the x-axis. It's very close to the line y equals 3/4. And on the right-hand side, once again, it's above the x-axis. It's very close to the line y equals 3/4. So if we set our scale on this, I think the easiest way would be to set the scale this way. Then y equals 3/4 would happen right here. On the second part of this example, we are to once again compare the degree of the numerator and the degree of the denominator. The degree of the numerator happens to be 1, and the degree of the denominator is 2. So the degree of the numerator is less than the degree of the denominator, which means that our horizontal asymptote happens at y equals 0, also known as the x-axis. And once again, we can graph this and see what happens with our function. So hit alpha y equals, pull in that fractional view, and start entering in your function. Once again, there may be some vertical asymptotes showing up, so just ignore what's happening in the middle of the graph and just focus on what's happening on the left-hand side and the right-hand side. So you see on the left-hand side, the function is very close to the x-axis. It's getting close to y equals 0. And on the right-hand side, it's doing the same. Also notice you can see that there's two vertical asymptotes happening as well. So that's good to see in this graph. And to find them, we can use the techniques from the previous video. This video, we're only interested in horizontal asymptotes. So I'm going to dot it in right here where it's right above the x-axis so you can see. Okay. Our next particular example, part C, we have a rational function again where we need to compare the numerator's degree and the denominator's degree. So the degree of the numerator is 2, and the degree of the denominator is 1. So in this case, the degree of the numerator is greater than the degree of the denominator. So we say there is not a horizontal asymptote. And we can see this on our graph. Let's go to y equals and clear out what we had before, and then type in our function. Focus on the end behaviors on the left and the right and see that this particular function is not approaching a horizontal line. Let me hit graph, and there we are. You can see the slant asymptote happening right in the middle of the page. We have our function on the left is slanting upwards to the left, and our function on the right is slanting downwards and to the right. So we can tell there's no horizontal asymptote on this particular graph.